Alrighty, I think what we're gonna do is, I don't know, I may make a new one. I don't want to, but I may. Anyway, I've got some of this Permatex aviation former gasket, which I don't know, I think I first was exposed to it as I was really little by my dad. He swore by it, and he was a pretty wise guy. That doesn't sound right. He was a wise man. So this did have, looks like a thin silicone seal on it, but I think this stuff will work pretty good. I think I'll wipe this with alcohol and we'll put it together with that. And if it leaks, well, I can always redo it, but I'm hoping it won't leak. So anyway, get that off of there. Okay, that's pretty good. The gasket's in good shape. There's just no reason to throw it away. It's not under pressure, other than, you know, there's no reciprocating parts in there, so it's not like it's gonna, shouldn't have any pressure, real pressure in there. So let's clean this up a little bit. So this is going as good as I could have hoped. So this goes in here. Oh, you got to be kidding me. All right, so this is, here's the difference between what they sent and what we got. I'm not sure what the best route is. So this is not long enough to put the snap ring on. This just sits flush. It's not even close to being long enough. So our choices are, we can counterbore this some more, which isn't too bad, right? We can put it on the mill and counterbore it, but then it makes this a little thinner. Not that there's a ton of pressure on here. Or I tap this out, the pin out, and remake this whole piece, including the flats. Not a horrible thing. It's drooling on my hand and the floor. Don't know what the best choice is. I really would like to maintain as much, because it's not even flush, and that's probably not going to matter. See, so it's going to sit in a lathe like this. It's going to stick out like that. Actually, I think it needs to be down like this. I think this is really wrong. Of course, it may be different on the other machine. I think what I'm going to do, of course, now that the lathe is apart, I can't make that part, but we do have another lathe, which I don't use very often, so maybe we'll fire up the other lathe. Because this really needs to be, yeah, maybe 1.5, 2. This really needs to be a couple millimeters longer. Let me get a caliper, measure it and see. So this is going as good as I could have hoped. So this goes in here. Oh, you got to be kidding me. All right, so this is, here's the difference between what they sent and what we got. I'm not sure what the best route is. So this is not long enough to put the snap ring on. This just sits flush. It's not even close to being long enough. So our choices are, we can counterbore this some more, which isn't too bad, right? We can put it on the mill and counterbore it, but then it makes this a little thinner. Not that there's a ton of pressure on here. Or I tap this out, the pin out, and remake this whole piece, including the flats. Not a horrible thing. It's drooling on my hand and the floor. Don't know what the best choice is. I really would like to maintain as much, because it's not even flush, and that's probably not going to matter. See, so it's going to sit in a lathe like this. It's going to stick out like that. Actually, I think it needs to be down like this. I think this is really wrong. Of course, it may be different on the other machine. I think what I'm going to do, of course, now that the lathe is apart, I can't make that part, but we do have another lathe, which I don't use very often, so maybe we'll fire up the other lathe. Because this really needs to be, maybe 1.5, 2. This really needs to be a couple millimeters longer. Let me get a caliper, measure it and see. Okay, so this is 15 mil. And then this is however deep it is, which is 2.86, so realistically 3 mil. 3.0, okay, I see. So that's 15, this is 3. So that means that the snap ring needs to be 12 millimeters from this edge, and this whole piece is probably 12 millimeters, 12.5. So realistically, and we can't have it stick in more than 15 because it'll hit the gasket. So realistically, we need to make this part, and this piece needs to be 2.5 millimeters longer with a new snap ring groove. So this has just become a much more involved project. Or we just counterbore this, which is way less time and work. And I use the brake very rarely. I mean, it's really, like I said, it's going to be mostly just to hold the thing stationary while I use the collets. Guess we should make sure these are the right size. Yeah, they look like they're the right size. You know, let's see, what is the diameter on this? That is 12 mil with a 20 millimeter counterbore. I've got metric counterbores, but I don't know if they'll fit that. Let's see. So this one's 11 millimeters. It's probably for a 10 millimeter or a 12 millimeter bolt clearance. Let's see. If it wants to come out of the little block, it is probably not even close to the right size. It's not. How about the snap ring? Because it's really only got to clear the snap ring. It'd be really close. Okay, so I don't have a 20 millimeter end mill. There's just no way. 3/4 inch is really close to 19, so I could do that pretty easy. The other option is I have a boring head, is we could take a boring head and just do that. Trying to decide what's the best option on here. Yeah, I'm a little worried about the angle of this thing. Of course, that might just be 180 degrees wrong. I don't know. Let's see. So this is going to sit like that in the lathe. Goes like this. And because of that pin, the brake shoes will be right there approximately. So this is, yeah, you know, that's going to be okay. Yeah. Well, crap. I'm going to guess that this is adequate because the other lathe uses this as a standard. This is a normal part. So I think I've just got to counterbore this deeper. I've got some regrind end mills. Maybe I can find something that's roughly the same size. If not, we're going to do it with a boring bar. Let me figure it out. I'll bring you back. Okay, I have decided we're doing this on the mill. So I've clamped this down to the table. That's all it needs, right? Because we're not going through. We're just going to relieve this top piece. To center it up, I've got some transfer punches. I got a, whoops, that's not it. I know I have a 12 millimeter. Yeah, instead of the 11, let's grab the 12. Anyway, that fits in there pretty good. So this doesn't have to be, you know, within a 1/10 indicated, right? Because we're just talking about a relief for the snap ring, the circlip. So I'm just going to put the drill chuck in here, use that to get this lined up. Then we'll set the boring head up and then just ease our way into it. We definitely need more height. That's pretty good. So we're going to call that centered, and I am going to zero the DRO just in case it moves, but I'm going to lock the table. And put in the boring head. Okay, I think this will do. It's pretty short. And we are definitely not going to need much reach. So I'm getting that lined up so that it's like a lathe tool, pretty much on center, hopefully. It'll be good enough for this. Put that in neutral for now. So we will, what size is that? 1/4? Nope. Yes, that was the wrong one. Okay. Okay. So the way I do this is I leave the middle one fairly snug so that it doesn't have a lot of slop when I adjust it, and then I snug the other two after adjusting. So I don't know if that will show up. Let me try to zoom in for you without it getting too janky. Okay. So what we're going to do is just adjust it till it just touches the outside, and I'm going to make note of the reading, right? So right now we're flush and on 0. So if we go 100 thou, which is 50 thousandths on the actual depth of cut, we're not touching. So, because what we're going to need to do is come back to this. Okay. So that is just touching. We're going to call that good right there. So that is actually 209 thousandths total. So about 100 thousandths depth of cut. Actually, that'll be good enough. Okay, so we're going to back that off. And we're going to take 50 thousandths off the diameter. So what we need to do is, now I've got to, so that is bumped up against this, and we need 2.5 thousandths off of this. Let me double check, right? So this is 3 deep, this is 15, and before we go cutting, right, I need this to be 9.5 roughly. Yeah, 9.5. So this is at 12. So we need to go down 2.5 millimeters. So I'm not gonna try that with the quill. I just zeroed the knee. So we'll drop this. I'll go turn on the phase converter. And we're going to do this in back gear, and we're going to go slow. So what we'll do is bring this up, I don't know. Actually, I'll go the 2.5 millimeters at 50 thousandths depth of cut, back it off, we'll move it out, do it, repeat 4 times. Okay, we are in back gear. Okay, everything's tight. I think we're good. So we're going to go down 2.5, back it out, go another 50 thousandths. So we just should take 4 passes basically. Let me zoom you out a little bit. So you can see our step right here. This is 2.5 deep, and we're this far out, so we'll just bring it over a little more and keep on going. Taking 50 thousandths per pass, which is 25 thousandths depth of cut, which, you know, we might could go more, but there's just no good reason to. Yeah, it's just touching a hair over here, not on that side. So we're going to go out another, I'm just going to give it about 10 thousandths and call it good. Okay, so the reason you hear a little chatter is I went down an extra 0.05 millimeters to give it a new bottom, just to allow a little clearance for that snap ring. It may not have been necessary, but I think it was good. So it was cutting that full width on the insert, which is fine. It's not like it's a super precise surface. So you can see, oh, you can see it better than I can in the camera. All right, let me back this out. Let's find out if it fits. All right, so what we're looking for is that snap ring to groove to show up, which it does, and it's definitely there. And the question is, do we have enough room to get the snap ring on? I think we do. Let me move the camera. So if this does fit, I'm not taking it. I don't want to take it back apart. So put a little oil on here. It's not like this needs to be polished. It's not a rotating, you know, high-speed part. It's just going to move that far every now and then. All right, let's see if this has enough depth. Where's my little screwdriver's over there? We'll use a center punch or a scriber. All right, is that in the slot? I need the screwdriver. All right. Let's see. Kind of looks like it, but Yeah, it looks like it is, just. It is. Oh, look at that. Just freewheels, just slides, and has, I don't know, tiny bit of in play. So that is a good result. So that was a lot easier than making a whole new part. I mean, I could, but I didn't really want to, and there's no need to. So I'm gonna put just a little oil on there for the seal. Okay. Okay, the seal's on. I don't want to push that up there without it being lined up. So I have cleaned the bolts with some alcohol, and I am going to put just a little bit of gasket stuff, sealer on the bolt, just to make sure that they don't drool. At least I hope not. So that is lined up. Get the other two in. Okay, that's on. And lined up. All right, that all turns good. So then there's this. Now the fun part, right? We're gonna fit that pivot bolt and then the brake shoes, I hope. Put a little blue Loctite on this just because I don't want it vibrating loose. And that looks like it might be 15 millimeters. Nope, 14. Let me get a wrench. All right, should be 14 mil. It is. Okay, we're good there. All right, I cleaned my hands with some alcohol just to keep them off of the shoes. So here's our brake shoes. This goes on the pivot, this goes on the flat. If you're gonna ever try this yourself and you don't want to spend 50 bucks, they are CG 125 or CG-125. Depending on where you look. It says CG 125 on there. The box has a hyphen. So, with any luck, right, these will just slip on here pretty easy. Oh, that one's on. That's on. Whoo daddy. So that works. I should put a little grease in there, which I can do, or a little oil. It's not like it's going to need much. Let's measure our distance here to make sure it's going to fit. Okay, we have 108.1, 108.3, 108.4, and we got 110 on the bore. So that will go. Beautiful. Hopefully it's centered up good enough. Before we put that on there, we've also got to figure out this rod, which is going to go from here. So I'm going to take a break and I'll come back in a little bit.